Hello everyone. In this video, we will be developing a recurrent neural network model for stock market prediction. So in this experiment, we will be developing a model, training the model using historical stock price data, which is the training data, and we will be evaluating its performance using testing data. And so in this experiment, we will be using two different data set, trainset.csv, which we will be using for training the RNN model, and then testset.csv, which we will be using for testing the trained RNN model. Both the data sets contain multiple columns, but we will be concerned only about the column open, as we will be using opening price of the stock as a feature for predicting the future stock prices. So let's get into the coding. Initially, we will be importing all the necessary libraries which we will be using in this experiment. NumPy is used for numerical operations, matplotlib for plotting, pandas for data manipulation. For reading the CSV file data, we will be using pandas. Then from sklearn.preprocessing, we will be importing minmax scaler for data normalization. Then for building the neural network model, we will be importing layers and sequential from Keras. Then we will be reading the training data set using pandas. Then we will be printing the column names of the trainset.csv file. Then we will be displaying first few rows of the data set using .head function. Then we will be extracting the values from the second column of the training data set. That is, we will be concerned only about the open column from the training data set. Then we will be printing the type of the train underscore set, and then the shape of train underscore set will be printed. Then using minmax scaler, we will be scaling the data between 0 and 1. Then after scaling the values, we will be having the shape of scale training set to be 1259, 1. So here we will be declaring the training data for the RNN model. The for loop creates a sequence of 60 time steps for the input x underscore train and the corresponding target values y underscore train. So the input ranges from 60 to 1259. So as we will be concerned only about the open column, from the open column we will be taking the input as well as their corresponding output. From the column open, the first 60 rows will be considered as the input, and the 61st row will be considered as the corresponding output. So this is how the x train and y train values are declared. So for the range of 60 to 1259, for each iteration, the first 60 rows will be the input and the next row will be its corresponding output. So when I is equal to 0, the input would range from 0 to 59th column, and the corresponding output would be the 60th row. When I is equal to 1, the input is from 1 to 60 and the corresponding output is the 61st row. When I is equal to 2, the input would range from 2 to 61 and the corresponding would be the row 62. Likewise, the x train, y train values are found. Then we will be using dot shape to check the shape of the x underscore train. Then we will be declaring variable length is equal to 60 and then n underscore feature as 1. So let's create the model. Model is equal to sequential. It initializes a sequential model. Then we will be adding a simple RNN layer with 50 units. Here in input shape, we will be declaring the length and n feature. Instead of declaring input shape as length comma n underscore feature, we can also declare it as 60 comma 1. Then we will be adding a dense layer with 1 unit for the output. Then we will be compiling the model using optimizer and loss. Optimizer used here is Adam and the loss mentioned over here is mean squared error. Then using model.summary, we will be printing the summary of the model architecture. Then we will be training the model using model.fit with epochs of 100 and batch size of 32. So now we will be reading the test data set and performing all the steps which we performed in the training data set. So using pandas, we will be reading the testset.csv. Then we will be displaying the first few rows of the test data set. Then we will be extracting the values from the second column of the test data set, which is the open column, then printing its shape. Then we will be concatenating the open column from both the training and test data set. Then we will be storing the values of dataset underscore total in inputs and we will be reshaping it. to a single column. Then we will be performing min-max scalar to reduce the values from 0 to 1. Then we will be declaring a for loop which ranges from 60 to 1384, starts from the index 60 and iterates until the end of the test data. Then we will be converting x underscore text to numpy array. Then we will be reshaping the values of x underscore test. Then we will be printing the shape of x underscore test. Then here comes the prediction part. Using model.predict, we will be predicting the stock prices using train model, and then we will be applying inverse transform to get the actual stock price. Using inverse underscore transform is necessary because during the pre-processing, the original stock prices were scaled using min-max scalar to the range of 0 and 1 for better training performance. So we are retrieving this transformation to get the prediction in the original scale. Then finally we will be plotting the real stock prices against the predicted stock prices using matplotlib. Thank you.